In the unit on statistics, we've learned how to calculate all of our summary and descriptive statistics manually, which is important for our understanding. Manual calculations are fine when the data is small and uncomplicated. Technology can be used for more complex data sets. In this video, we won't show you how to calculate anything manually. We'll show you how to find summary or descriptive statistics using the statistics function on your graphics calculator. In this video, we're going to have a look at how to calculate the mean, median, mode, the minimum and maximum values, the quartiles, the standard deviation. Then we're going to have a look at calculating probabilities and quantiles on your graphics calculator. Some of the more common graphics calculators are displayed here. Over the last 15 years, they haven't changed very much. This means you might be able to use an older calculator and still get away with it. In this video, I'll be using the Casio calculators on the left of the screen. In my previous video on measures of center, measures of spread, and the standard deviation, we learned how to calculate the summary or descriptive statistics manually for this dataset. I'll now show you how to calculate these using the graphics calculator. Let's find the summary or descriptive statistics for this population dataset. Here we have the main menu of two different Casio calculators. Press 2 for statistics and we get the lists. Enter the data values, pressing execute to go down to the next line. You can also navigate with the arrow buttons. Press F2 for calc, which changes the options on the bottom of the screen. Press F1 for one var or variable to attain the measures. In the previous example, we found the population mean was approximately 72. The actual value is 71.7 highlighted here. We used the approximate mean to calculate the population standard deviation. Remember, this is calculated slightly different to a sample standard deviation. Both measures are provided, but I have highlighted here the population standard deviation, which is approximately 13.3, which is the same as what we got when we calculated it manually. If we arrow down, you'll find such things as the minimum value, the first quartile or Q1, or the lower quartile, the median, Q3, which is also the upper quartile, the maximum value and the mode. This dataset doesn't have a mode, so each value will be listed individually. Whilst you're expected to be able to calculate these, you'll notice that having a graphics calculator will be very useful for checking your answers. You'll notice that the statistics package works the same on these two different Casio calculators. In my video on measures of center from tables and charts, we found that the measures of center from a tally and frequency table. It's also possible to calculate the measures of spread using the data from this table, but to calculate them manually would be quite tedious. Instead, we'll use the graphics calculator to find them. Here we have the same data from the previous slide, but I've reduced the table to only two columns, the data value and its frequency. I'll only show you the Casio FX CG20 here, as I've proven both operate in the same way for this function. This time we have a frequency table though, so we're going to have to change one of the settings. Again, we start with the main menu. We press 2 for statistics. You enter your data values into the list 1 and press execute to get to the next line. You can also navigate with the arrows. The difference to the previous example is that we have to enter the frequency in the list 2. So we press 2 for calc, which changes the options on the bottom of the screen. This time we're going to press F6 for set. And you arrow down to 1 var freq, which is the frequency for the first variable. You press F2 for list and then press number 2, and this makes the list 2 the frequency of list 1. Then press exit to go back to the lists. Press F1 or 1 var again to attain the measures. As this was a sample, this time we are looking at the sample standard deviation, which is 5.05. We can also confirm the other summary statistics that we calculated manually by arrowing down, and there they are there, and I'll let you look between the two slides. In my normal distribution video, we explored the proportion of values that fell within 1, 2, and 3 standard deviations from the mean. As proportions are constant, we were able to work out the percentage of observations above or below certain observations. This allowed us to work out the probability that an observation fell within a range. In a survey of year 8 students, we wanted to know the percentage that were below 115 centimeters tall, which is about 2.28%. Then we found the probability of randomly selecting a student below 115 centimeters tall, which was 0.0228. Now we use the graphics calculator to find this probability. Both the Casios operate in the same way. Again, we'll start the main menu. Press 2 for statistics and we get the lists. We leave them blank this time. We press F5 for dist, which is distribution. Then we press F1 for norm, which stands for normal. Press F2 for NCD, which stands for normal cumulative distribution. Here we enter our data. We make sure the data option is variable if that is an option on your calculator. On the Casio FX CG20 it is. It isn't an option on the Casio 9860. Because we are finding the probability a student selected is under 115 centimeters, our lower bound is a really small number. I entered -10 to the power of 99, and the upper bound was 115. Enter the standard deviation and the mean, then arrow down to execute and calculate. Now we're given the probability, which is P equals to 0.0228 rounded to three decimal places, which matches our previous slide. Let's look at another example. The circumference of mature apples is normally distributed. The mean size is 250 millimeters and the standard deviation is 5 millimeters. To meet quality standards, the apples supplied to a supermarket must be within 1 standard deviation of the mean. Here we calculated the probability an apple would be rejected, which was any apple outside 1 standard deviation from the mean. The probability one would be rejected was 0.3174. Let's use the graphics calculator to find this probability. Because we're looking at the probability something is both greater than or less than the standard deviation from the mean, we'll calculate the probability an apple is within 1 standard deviation, then minus that from 1 to get the probability it is outside of 1 standard deviation. The lower bound will be the mean minus 1 standard deviation, which is 245 millimeters, and the upper bound will be 255 millimeters. Again, we start at the main menu, we press 2 for statistics. Again, we leave the list blank. We press F5 for dist, which is distribution. Press F1 for norm, which is normal. Then we press F2 for NCD, which stands for normal cumulative distribution. Here we enter our data. Remember to change the data option to variable. This doesn't have to be done on the Casio 9860. We're finding the probability something is within 1 standard deviation from the mean so that we can take this away from 1. The lower bound is 245, the upper bound is 255. Enter the standard deviation and mean, then arrow down and execute. Now we're given the probability. P is approximately 0.6826, which is the probability an apple would be accepted, but we've been asked what the probability an apple won't be accepted is. So we take this probability away from 1 to get the probability it won't be accepted, which is the 0.3174, which is what we got earlier. When finding percentages or probabilities, we're given a measurement and then asked to find the relative percentage probability. When finding quantiles, we're given a probability and we're asked to calculate the corresponding measurement. This is the inverse of finding probabilities. To find quantiles, we use the inverse normal function on our graphics calculator. In the last example, we were calculating the percentages and probability for below and outside a certain deviation from the mean. Sometimes we might want to use the percentage or probability of something occurring to find the measurement. Consider university exam results with a K-score are normally distributed with a mean of 70 marks and a standard deviation of 5 marks. Only the top 5% of students are going to receive an award. The bottom 10 fail and must repeat the course. So we're going to find the K-score where the probability someone will fail is the probability of the score being less than K equals 0.1 or 10%. And we know using the percentages on our normal distribution that that's going to fall somewhere between 60 and 65, because if we add together the percentages from the left-hand side, so 0.13 plus 2.15, and then we make up the percentage up to 10%, it's going to fall somewhere between 60 and 65. So I've estimated here where that will be. The probability someone will receive an award is probability of the score being greater than or equal to K, which is equal to 0.95. So we want to find the top 5% and I've marked that here in green. So again, similar to when they fail, I've tried to estimate where the top 5% will lie. So we can see it's going to be somewhere between a score of 75 and 80, but closer to 80. Let's look at it on the graphics calculator. First, we'll look at the minimum score you must get to pass the course or you'll fail. Again, we start at the main menu. We press 2 for statistics. We leave the list blank. Press F5 for dist, which is distribution. Press F1 for norm, which is normal. And this time, we're going to use inverse normal. So we're going to press F3. And then we get our list where we enter our data values. Because we're looking at the fails first, we're looking at scores left of the mean. And therefore, we're in the left tail of the normal distribution. The area is 0.1, which is the probability someone might fail. Enter the standard deviation and mean, then arrow down and execute and calculate. Now we're given the cutoff score, which is approximately 63.59. Therefore, to fail, you would have to score below 64 in the exam. I've rounded that up. Let's find out what score someone would need to achieve an award. Again, we start with the main menu. We press 2 for statistics. Press F5 for distribution. Then we press F1 for norm. And then again, we press F3 for inverse normal. Here we enter our data. We're looking at scores to the right of the mean, or the right tail, which is the right-hand side of the normal distribution. The area is 0.05 because we're looking at the top 5% this time. Enter the standard deviation and mean, then you arrow down and press execute. Now we're given the cutoff score, which is 78.22. Therefore, to receive an award, you'd have to be above this. So I think you'd have to probably score 79 marks to receive an award. So in summary, in this video, we've looked at how to calculate the mean, median, and mode, the minimum and maximum, the quartiles, the standard deviation. Then we had to look at calculating probabilities and quantiles on the graphics calculator. Thank you.